rules for exponents we're going to go over. One is called the product property. That means product means you're multiplying, and you're going to really end up adding the exponents. And then we have the quotient property, where you divide, where you end up subtracting the exponents. Okay, so you might want to just put, you're adding the exponents. That's what that means. So if you have something that says a to the m times a to the n, then you're actually adding the two numbers together. All right. And then, so just to kind of review where it says product property, I want you to write this in there. Okay, a to the m times a to the n, or is it already written for you? Okay, equals the adding together. And then they actually give you like an example where you have some numbers. So you just say 2 plus 3 is 5. Okay, again, this should be more of a review. And then you can see why it works, because if you have x to the second, that means x times x. If you have x to the third, that means 3 of these. And so when you add them all together, you have a total of 5. Okay? So just explaining to you why the rule works. So these are very simple, basic ones. So again, you have the same base. The base is the x. You add your exponents together. So that's just going to give you x to the 7th. Okay, you just simply write x to the 7th. Okay. Number 2, remember there's an invisible 1 here. So keep that in mind, because every base has an exponent. And when you don't see it, it is the number 1. So you just add 2 plus 5 plus 1. Okay, you get a total of a to the 8th. Number 3, this one actually has a -6 and a -2. And since this is multiplication, we are multiplying them together. And then we add the exponent. So that's -12 m to the 8th. Number 4, again, you can multiply the 4 times the 3, and technically there's a 1 here, okay, but 4 times 3 is 12, and then you add up all of your exponents. 9 plus 4 plus 3 gives you 16. There's a very easy rule, and it doesn't matter how many different variables you have, but just make sure you're only adding y's to y's and z's to z's. So 3 times 7 is 21. You have a total of 6 y's, total of 9 z's. Okay, same thing here. 8 times 5 will give you 40. You add up your a's. 6 plus 5 is 11. Don't forget that 1 here. So 1 plus 7 is 8. And then 3 plus a 1 is 4. Okay. Now, for the quotient rule, we just do the opposite rule that we did for multiplication. So now we're going to subtract. Okay. So you should already have this on your foldable. Subtract the exponents. So if you have 5 minus 2, that's going to give you x to the 3rd. Why it works? Here it is. You have 5 at the top, 2 at the bottom. You cross out the pairs, and you can see you have 3 left. Okay. All right, so here we go. Same base, subtract. Okay, you get x to the 5th. Same base, you subtract. So that gives you v to the 8th. All right, now you can divide with numbers like we normally do. So 27 divided by 9 is 3. Then subtract your exponents, and you get 4. Now, when we get to the other foldable, you're going to see what happens if these numbers had been reversed, and we had the 6 at the top and the 10 at the bottom. Then, of course, we have to do something a little differently there for negative exponents. All right, so here we go again. You will reduce the 6 over 30. It's not 30 over 6. So that's technically 1/5. You don't need to write the 1. And then when you subtract the exponents, you get n to the 2nd. Okay, any questions on that? Okay. All right, here's number 11. 42 can actually, 6 can actually go into 42 7 times. And then you subtract your F's and you subtract your G's. Now notice here, this says 6 minus 7. So this is 6 minus 7 actually gives you what? -1. So when that exponent is negative, then we drop that particular one in the denominator to make it positive. So we're going to do more like that on the next foldable, so you'll definitely see why that's true. Now, if you actually expanded it out, you know how you say, why does this work? You'll end up with the G at the bottom. Okay, because if you have 6 at the top and 7 at the bottom, you cross out the pairs, you're going to still have that 1 left at the bottom. Okay, but there's a rule for that as well. Okay, go ahead and do that one if you haven't done it already. Just reduce to 12 over 32. What's the largest number that can go into 12 and 32? What is that? Okay, so 4 goes into 12 3 times and into 32 8. Now, when I subtract my C's, I have 5. And this should be a D, guys. Let me change that. And then you should have a D here for the 3. Here we go. Okay. And we can go over how to fold it later at the end once we fill it in. Okay. All right, so let's start the, this is where, like, if you're subtracting and you end up with a negative exponent, or you end up with an exponent that says 0, okay? Anything to the 0 power is 1, okay? And I can prove that later. But you do need to know that if you get 0 as an exponent, you just simply write 1. That could be the base could be a variable, the base could be a number, like here, okay, a decimal. If the exponent is 0, that really means that you are dividing a number into itself. For instance, okay, everybody knows this. So if I have a to the second divided by a to the second, well, we just went over the quotient rule, which says you subtract the exponents, correct? So 2 minus 2 is 0. But we also know from a long time ago, when you divide anything into itself, it equals to 1 whole. So really, when you're getting 0 as an exponent, that means the numerator and denominator had to be the same number. Okay, same thing if I ask you this question, and if I say, what is 4 divided by 4? Obviously, you're going to say what? 1. Okay, now remember I told you every number and every variable has an exponent. So what is the exponent to these 4s? 1. It all works out. Okay, so it doesn't matter. Whenever 0 becomes an exponent, that means you are dividing something into itself. Okay, the same term. All right, so negative exponent rule means if you get a negative exponent, what you're going to do is you're going to take the reciprocal of it to make it positive. Okay, that's what really ends up happening. So bottom line is we cannot leave negative exponents in our final answer. Okay, so if you had 3 to the negative 4, you're going to write it as 1 over 3 to the positive 4. Okay, that means you just simply take the reciprocal of it. Now, of course, you can say 3 times 3 times 3 times 3 is 81. Be very careful of this one here. Good thing this one is in parentheses. So you are taking the reciprocal of all of this. So that's 1 over all of that raised to the positive 2. So the only thing that becomes positive is the exponent, not what's inside of here, not what's, the base. If the base is negative, either, with or without parentheses, it's going to stay that way. Okay, you're only changing the exponent to have a positive number when you take the reciprocal. Okay, now I can prove this as well. So let's just take a look so you'll know why this is true as well. Like why do you take the reciprocal and then it becomes positive? So if I had 10 to the third power, 10 to the second power, okay, 10 to the first, 10 to the 0, then I'm going to start getting into negative exponents. So we already know that 10 to the third power is what? What's 10 times 10 times 10? All right, so here we go. So this is 1,000, this is 100, and this is 10. Is that true? So if you notice, what we're really doing is when we go from here to here and from here to here, we are actually dividing by the base. What is the base in this number that I'm using? 10. All right, this is your base, right? So each time we are dividing by 10 to get to the next one. And here's again, we divide, what's 10 divided by 10? There we go again. Now we just proved that again. All right. So if we divide by 10 again, we're at what? 110. All right. That's why once you start getting to those negative exponents, it becomes a fraction. Okay. So I'd like to not only just say, remember the rule, you need to know why the rule is true. Okay. All right. Let's move on. So here's our first example. So we have 7 to the negative second. So remember now, we are in that negative, so we're going to take the reciprocal and make it positive. And again, the only thing that becomes positive is the exponent, right? So we can say 7 times 7 then is 49. Okay. All right. So here, anything to the 0 power, what should we write? Okay, 1. We already know that means that you're dividing a number into itself. Okay. Now for this one right here, this is actually already in the denominator. So keep thinking that when we have these negative exponents and we take the reciprocal, of course, if it's in the numerator, then when we take the reciprocal, it drops down to the denominator. But what if it starts out in the denominator? Where do we do that? It goes to the, correct, it goes to the top. Reciprocal just means you reverse it. So if it's already down here, you're going to reverse that, and you end up with -4 to the +2. And again, the base does not become positive, only the exponent. Okay, now of course, a -4 times a -4 will give us a +16. Okay. All right, so here we take the reciprocal because that negative exponent is really at the top. Because, you know, there's like an invisible 1 here. So when we take the reciprocal, we get 1/9. Okay. Number 5. All right, what do you think the answer is? It's not 1. It's actually -1. Now, it would have been 1 if they had done this, because then I'm also raising the negative to the 0 power. Okay, but here, this is only attached to here because it is not in parentheses. So when I do 5 to the 0, it's to the, 5 to the 0 is 1, but then I multiply it by the negative, that's going to give me -1. So there's a difference between these two questions. I just want you to be very aware of that. Okay, number 6. Okay, I'm going to take the reciprocal, 1/2 to the +5th, and then you can tell me that 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 30. What's 8 times 2? 16, and 16 times 2 is what? 32. Okay. All right, now this one, all of this is being raised to the -2nd. So when I take the reciprocal, I'm going to do it this way. And then I end up with 1/16. Okay. You're not squaring the negative. All right. Let's move on to here. So it says simplify each expression. For this one, I already know y to the 0 power is 1. So 1 times 7 will give me just 7. So you end up with 7x. Okay, because this is, okay, thank you. This is going to be a 1 here. When you multiply 1 times 7, you get 7, and then the x stays. You can't simplify that any further. So the answer is 7x. Okay, for here, we're going to move this to the top, and we just end up with m to the third. All right. For number 11, this -4 is only attached to the d. It is not attached to the 5. Okay, so you're going to leave the 5 where it is. You're going to put this as d to the 4th in the denominator. Okay. All right, so for here, we already know n to the 0 is 1. Okay, so I'm just going to, put a line through it. You don't really need to, in this case, we actually will have to write the 1 because this is going to be going in the denominator. So we'll need to have that 1 at the top. So again, the only thing that the -3 is attached to is the e. So the f to the 5th will stay in the numerator. And we'll drop the e and make that a +3. Okay, anything that has a positive exponent already does not need to take the reciprocal of. Okay. All right, let's take a look. The only thing that has a negative exponent is this b. Everything else can stay where it is. So the 3a will stay at the top, the 5, and then I'm going to put the b in between, so I'll have it in alphabetical order. Okay. All right. And then for this one here, again, this is 1, so we're not going to need it because 1 times 9 is 9. We're going to drop this y to the bottom, and we're going to move the z to the top. Okay. So this is just a matter of moving things up and down based if it was negative or positive. Okay. Positive stays where it is. So here, we're going to take this 2 to the -3rd. We're going to put it down here as 2 to the +3rd. We will definitely change that to 8 in a minute. We're going to also take the m to the n to the -9, make that a +9. And the m to the 5th will stay where it is because it's already positive. And then we'll just simplify this to an 8 and to the 9th. Okay. All right, so do you guys recall this lesson from last year? All right, great.